Right, hello everyone. This is the beginner's guide to the Linux checklist. So in order to get to the Linux checklist, you want to go to drive.defsec.club. That should bring you here to the training folder. And then you're going to want to go into Nix, checklists, and then you're going to want to look at the Debian checklist. We have various checklists for different distros in Linux. You'll probably get into like CentOS and FreeBSD later on, but for the upcoming Cyber Conquest, the Debian checklist should do you just fine. So this is the checklist. I'm going to walk you through all of this and try to explain it as best as I can. Oops. And hopefully it'll be nice and simple for you. So let's get started. Debian checklist, your guide to peace and success. So first thing you want to do on a Linux system is you want to log in. Typically in our competitions you can log in as root. Otherwise you should be able to log in as DSU. I'll show you this way first. Oops. Password is typically password1 exclamation point, but it could be different depending on the competition. A little bit of weirdness there. I'll get into that later on. From here you use sudo su, password1 bang again. So like we talked about in the first week of Linux 101, sudo is super user do, so it's kind of like run as administrator, and su is switch user. So when you call a switch user with no arguments, it just makes you root the admin user instead of some other user. Once we're root, then we can get into the root home directory and things like that. Alternatively, you can log in directly as root. Typically in our competitions, this isn't always going to be the case, but in ours it usually is. So you can log in as root with the password password1 bang. I'm going to hit clear again. So first thing we do in the Linux checklist is check our initial state. So what we're trying to do here is we're trying to create a baseline of the state of the system hopefully before Red Team has gotten the chance to mess around in here. So we can look back at this information later on in order to tell if Red Team has messed around with anything. So the first command we're going to run is psaux. I'll just show you the output of that first. So ps is basically a process list. AUX is a bunch of arguments that give us a bunch, basically the columns that we want to see and the processes that we want to see. There's a whole bunch of stuff in here. Most of it's not going to seem super intuitive. Usually the process IDs that you see on the left here, the higher the process ID, the earlier it came in the startup sequence. So stuff we at the top is usually kernel related. And as we scroll down, we'll get down into more user space processes. So we can see here we have DH client, which is doing our DHCP for the networking. We have RPC bind, which is another networking process. And then down closer to the bottom, we see we have Apache, which is our web server. And we see some other weird things that I'll get into later as well. Yeah. So the first thing we want to do is we do psaux, and then we're going to redirect the output of this command into a file. We're going to call it ps.list. And later on we can go into and cat ps.list and see what was on our system right at the beginning of the competition. Similarly, lsmod lists our kernel modules. So kernel modules are sort of low-level pieces of software that kind of are in between you and the hardware of the system. So you can think of like drivers, things like that. NetFilter, which is the underlying system for our firewall, is a kernel module. If Red Team gets in here, they can insert kernel modules or remove kernel modules that can basically rootkit your system, things like that. So this is a good thing to have as a baseline as well. So we're going to put that into a file called mod.list. And then finally we're going to cat etc password. So in etc password we have a list of all of our user accounts and information about them, what groups they might be in, the home directory of the user, as well as the shell of the user. So this is a good thing to have as a baseline, because one of the first things Red Team wants to do when they get on your system is add new user accounts, give them administrator privileges so that they can get back in and mess around later on. So this is a good thing to have as a baseline as well. So we're going to throw this into users.list. So now I have all of our baseline things. We can start getting into actually securing the system. So the first thing we want to do is change the root password. This is the most important thing that you're going to do on the system, obviously. So in order to change the root password, we do PASSWD for password and hit enter. It'll ask you for your new password. I'm going to do password2@, but you should make it very complicated and good. Ideally, it should be something like 3 words strung together with a couple of numbers at the end, or something like that. You don't want to make it too random, because obviously that's going to be hard to remember, and more importantly, it's going to be hard to type. If you have a hard to type password, that is very, very bad. I'm going to make sure I'm recording here. Okay, I'm good. After we've done this, and this is very, very important for the next step. So make sure that your password has been updated successfully. If this fails, you do not want to do this next step. So the next thing we're going to do is restrict Sudoers. So basically what we're doing here is we're trying to restrict who can become root, who has admin privileges. And what we want to do in competitions, what you may not want to do in real life, is we want to restrict admin privileges to the root user only. So you have to log in as root in order to have admin privileges. You can't get admin privileges from some other user account. So we're going to do sudo. Sudo is a special command that will open up this Sudoers file and make sure that you don't screw it up. Because if you try to open this manually with like nano, it will just not, and you mess up the format, it'll break everything, and then you won't be able to log in as root or do anything at all. Your just admin accounts will be just totally destroyed, and that's very, very bad. So what we want to do in here is we want to remove all lines except for this root all and keep the default stuff. So we're going to leave all this stuff up here. Oops. We're going to keep all of the stuff up here with its defaults, and we're going to keep this line here with this root all. Everything else we're going to want to get rid of. So what this line here is doing, this %sudo, is it's saying everyone in the sudo group has admin privileges, and we don't want that to be the case. So in order to delete that, we're going to do Control-K since we're in nano, and that'll cut and delete that line. And then this is a little bit sneaky. This include dir etc sudoers.d. What this is saying is that we want to include all the files in etc sudoers.d as though they were a part of this file. So this little hash sign is not a comment, it's actually an include directive. So we want to delete this line as well, so that people can't just drop stuff in etc sudoers.d, so that people can become admin users later. So we're going to do a Control-K here as well. Then we'll hit Control-X to save, and hit yes, and we'll save. And if you screw up, sudo should catch that and stop you from actually destroying your Sudoers file. So it's always a good idea to use sudo instead of editing Sudoers directly. So next up is we're going to change system passwords. So we're going to change the passwords for all the user accounts on the system. And we have this nice, really compact script, which is kind of hard for beginners to understand. So I'm going to go through it step by step. This part up here, this read, is not super important until we get into the script portion, but I'll go right into this part here. So the first thing we're going to do is get ent password. So that's sort of like get entity password. So this grabs, basically it just cats the etc password file. Although if you have some extra systems, say you're connected to an Active Directory domain, this will also pull users from Active Directory. It can also pull users from an LDAP server, something like that. If you have other systems set up to be able to authenticate against other than just this local system. So that's what getEnt password does. And what we're going to do is we're going to pipe that into grep and -v root. So what this is doing is it's taking the output from getEnt password and it's removing any line that has the word root in it. Because when we do our password changes for all the system passwords, we don't want to include root because we already changed the password for root. And typically we want our root password to be different from our system user passwords, so that if our system users get exploited somehow, or if someone steals a user password through some service, our root password is still okay, and that's separate, and it won't get compromised. So we do that, and we see that root is no longer in our list. And then finally, we're going to pipe that to cut -d :-f1. So what this cut does is it's sort of like a split. If you've done a little programming, what it's doing is it's going to split every line in the output on the delimiter -d of a colon. So it's going to split this on every colon, and then -f means we're going to take this piece of it. So we're going to take the piece, we're going to take the first piece of it. So basically we're going to take, from every line we're going to take just the user account name. So when we do this, then we just have a bunch of user account names. Now a lot of the stuff in here is just system users, so changing their passwords isn't going to really do anything, but it'll also catch all of our actual regular users as well. So then after all this, we encapsulate it in a $ and parentheses, and this is just a way of capturing the output of something and putting it into a variable. So our variable is going to be users, so we'll do users equals this, and now if we echo users, $users, that's how you get the value of a variable in Bash. It'll output all of the user accounts, and they're just space separated because when you capture the output of a command like we did in this, it turns all the new lines into spaces instead. And then what we're going to do is we're going to do a for loop. So we do for user and users. This is going to take every piece of every user account that we have in our variable users. Oops. We're going to do, and then echo user pass. And I'll just show you what this does first. And since the pass variable doesn't exist, this doesn't do anything yet, but here you put some password, so you do like blurp 5. And then what this does is it outputs user account : and then the password. And what we can do with this is we can pipe it into the command chpassword. And this is a special version of password which takes a user account : and a password and changes the password for the user account to the password that you give it. And this is a really fast way to do a scripted password change. So we can do that all at once here. Chpassword. And then boom, we have, oh, forgot, I need to change this, 3#, gotta be careful. So the error I got there is because the pass variable didn't have anything in it, so it just looked like a blank password, and that's not allowed. So after doing all this, all of the user accounts on the system, apart from root, have had their password changed to password3#. So if you want to put this onto a script, do nano. I'll do change pass.sh. We do a hash !bin sh. This is not strictly necessary, but if you make this script executable, what this does is it tells the system what interpreter to use in order to run this script. So we're telling it to use bin sh. We're going to read -p : pass. So what this does is it says take input from the user, and with the prompt : so it'll just show a little colon, and then put it into the variable pass. And then we'll do these same commands that we did earlier. And then we're done. If you see on the actual checklist, we have this extra command here, which tells the script to echo the user and password to a system name.csv file. So what this does is it outputs all the user accounts and the passwords that it's changed the password to. In certain competitions, they will force you to list every user account and password individually that you change on a system in order to change it in their scoring engine. In our systems, you will not have to do that, so you can ignore this line. After you change system user passwords, you're going to want to go into the scoring engine and change passwords there. I'll try to pull up the scoring engine user guide here. This is not it. Here it is. I'll put a link to this in the DevSec channel later. So basically you're going to want to, after you've changed your passwords for your users, jumping back here for a second, so hit save this, and to run this you just run sh and then change path.sh. Oops. And then you'll type in your password here, and then that'll change the passwords for all your user accounts. So after you've done this, you're going to have some scored services on your system, and changing all those passwords may have changed the passwords for some user accounts that the scoring engine is using to score your system. So what you need to do is log into the scoring engine. You'll be provided with credentials probably a day or the day of the competition, and you'll just log into the scoring engine, and then you're going to go to password change requests. You're going to create a new request like this, and then you'll put in your credential type, which will probably be local for Linux systems, and then your service. So it'll say like the name of your system hyphen the service you're changing the passwords for. So you're probably going to want to change it for SSH. So you do like Linux 1-SSH, and then you would put in the scrolling down here, you would use the all keyword. So you'd say you want to change all passwords to the one you set here. So all : secure password, and then you would submit that, and then that should run through the scoring engine within 30 seconds or so. So, getting back to the checklist. Now we've done the very, very most important things. So the next things we want to do is we want to make a local backup of all of our stuff. So, one of the things that often happens in these competitions is that while you're trying to go around and secure things, you accidentally break things. That's one of the worst things that can happen in a competition, because oftentimes you're doing so many different things that you, when you mess up, you don't remember where you messed up or what specifically caused everything to break. So one of the first things you want to do is create do the initial state local backup. So you want to make a backup of all your stuff so that you can restore it later on. So the way we do this is we're going to make a directory with make dir root/back. You can put it wherever you want. And then we're going to copy -r for recursively. So we're going to copy everything in this directory /etc to /root/back. So that's going to copy the entire etc directory. So all of our config files will get copied into root/back. And then copy -r/home. So we're going to copy the home directories of all the users into root/back. And then depending on what services are on your system, you may want to copy other directories as well. So in this situation right here, our Debian system is running a web server and an SSH server. So the etc and home are going to cover all of the SSH server, and it also covers the configuration files for the web server. But there are also some hosted web files, so some HTML files and things like that, that are going to be held in /var/www, and we'll put those in root/back as well. So if we ls root/back, we have all of our stuff here. So, depending on your setup, this may take a very long time to copy all those files, so you can put this into a script and then just run it in the background. So you make a script like backup.sh, and then you'd run it in the background by doing something like this. So you do sh backup.sh and then ampersand. Ampersand makes it run in the background rather than running in the foreground. But we don't need to do that. So after this, the next thing you want to do is change application passwords. So if we go back into our training folder, Oops. We go into Nix and checklists and application checklists. So we have a bunch of application checklists for different applications. This is typically pretty simple. So if you look at the SSH checklist, you typically are going to want to do this a little bit later on. We can get to that later, I believe. Yes, down here. And we're only worried about changing passwords at this point. So sometimes that's a little bit tricky. So you can change like web app passwords in the actual MySQL databases manually. Otherwise, typically on a web server, what we found is the easiest is to just do it through the actual website. So you'll go to, say, a box with an actual GUI on it and a web browser. You'll navigate to your website and you'll try to log in. You'll try to log into your website as your admin user. You'll look around in there, poke around, change your passwords manually through that. Other things, typically the real thing that we're trying to cover with this change application passwords is database stuff. So you have like your database checklists. So if you're running a database like MySQL, you'll want to run through basically the first three or four parts of this to lock down the user accounts on MySQL, because those are probably one of the most important things after system passwords to actually have locked down. But if you want to read through that on your own, that's a good thing to get familiar with. But we can just skip past this basically. So after you've changed your application passwords either through your website or whatever, we're going to back up to checklists here, and we're going to jump into firewall scripts and Iptables. So what we're going to do is do inbound firewall here, and this is probably one of the most important steps to do. So we're going to get deeper into Iptables on Tuesday, but this is just a quick run through of the actual firewall script. So the first thing we do is do iptables-f. This flushes the current rule set. This can be a little bit dangerous if you're working on a system remotely, because if default policies are set improperly, you can actually lock yourself out of the system. You shouldn't have an issue with this in this competition because you'll have direct console access in the IA lab. Then we'll do iptables-x. This deletes custom chains, which you probably shouldn't have any. And then we'll do iptables-p. This is for setting policy. So we're going to set our input policy to drop. We'll set our output policy to drop. And we'll set our forward policy to drop. Oops. So if you do iptables-L, this will list your current rule set and your default policies. So we see we have a chain for input, chain for forward, chain for output. Our default policy for all of them are drop, and we have no rules in our rule sets. Oops, that should not happen. And so the next thing we do here is we do iptables-a input. So that's append to the input chain. We're going to load a module called state related established. We accept. So what this rule is basically saying is that if we have a packet that we let out, we also want to let the response back in. So if we're talking out to some web server and we allow that traffic outbound, we want to allow the web server to be able to respond to us without having to have a specific rule for that. So we do that like this, and then we'll do the same thing for output. So if we allow some traffic in, say to SSH or to our web server, we want to also allow that traffic to go back out to the client. There's some stuff about passive FTP, which isn't super important. You can dig into that on your own if you want to. We'll get more into that on Tuesday, I'm sure. And this is the important part here. So for each scored service, we're going to do this. Iptables -A for append to the input chain, -P the protocol, which is TCP in our case, vport for the destination port, 22, -J accept. So what this is saying is that we want to allow in, because we're jumping to the accept chain, we're going to allow on the input traffic coming to TCP port 22. So we want to allow in SSH traffic because we're running a scored SSH server on this system. And then we're going to do the same thing for port 80 on TCP because we want to allow in web traffic to the system as well. And then from here, you can also allow outbound So if you want to go out to the internet on this system for some reason, say you want to download updates or something like that, you can do destination port 80 outbound. You'd also want to have UDP 53 for DNS. I think that's about it for outbound stuff. You also want 443, that's right, for HTTPS. And now we can look at our rules. And we see we're allowing established and related, inbound and outbound. We're allowing SSH and HTTP in, and we're allowing HTTP, HTTPS, and DNS outbound. So now we have our firewall all set up. Now the important part is to make it persistent. So when you reboot a Linux system, all of your firewall rules get deleted, and you're just back fresh, allowing all in and out. This can be useful, especially if you accidentally screw up your firewall rules while you're working on a system remotely. And if that happens, you can just reboot the system, and then it'll be back to normal, and you can log in again. But if we have our stuff set up and we want to keep it that way, even if we reboot, we need to save our firewall rules. So we can do iptables -save. What this does is it basically outputs a sort of a script which is closer to what Iptables likes to deal with. It's less user focused and more the software focused stuff. So it's a little bit shorter and cleaner. So we'll output that into a file. We'll call it /root fw rules. And then we're going to echo iptables-restore. Actually, we can just nano etc rc.local. So rc.local is a script that runs on boot. And we can scroll down here. And just before the exit 0, we're going to put our command. So we're going to do iptables-restore /root/fw.rules. And we'll exit and save. And then we want to make sure that the startup file is executable, because if it's not, it might not run. So we make it executable. So now every time the system boots, it's going to run iptables restore root fw.rules, and it'll load up our rule set. So once you've gotten to this point, you've basically gotten your system about 75% secure. So what we've done here is that we're only allowing in traffic to our scored services, and usually you're only going to be allowing out traffic to places that your system needs to get to. If you have, like we do, a sort of global outbound to HTTP and HTTPS, that can be sort of a bad thing. So typically what we like to do is keep these three rules out of here. So if you want to delete a rule, you can do iptables-d and then the chain, which is output, and the number of the rule. So it starts at 1, 2, 3, 4. So we can delete rule 2 3 times, and that'll delete all of those outbound rules except for the first one. So if we want, typically we want to keep our system like this. So we don't allow anything out, but then we allow in the scored service traffic. But if you need to get outbound in order to like download updates or something, you'll have to add those rules in and then delete them afterward or something like that. If you have your system like this, you're only allowing traffic into your scored services, and you're not allowing any traffic outbound. So red team, the people who are attacking you, they don't have a lot of ways to actually get into your system. They're locked down to being able to log in with a valid user account over SSH, and they have to know the password, which you set earlier, or they have to have logged in before you got in order to do some shenanigans there, or they have to have dropped something on your web server already, or they have to have user account credentials to your web server in order to get in on HTTP. So right here, we're basically 75–80% of the way there. So the next thing we do is we check the services that are running on the system. So to do that, you can do netstat nlp. So do this. I prefer lsof npi. So basically what this does is it shows all of the processes that are running on the system that are listening or connected to connected outbound. So here we see we're running DH client. It's listening on port 68. We have RPC bind. We have RPC stat D. We have SSHD, XM4, NC, Apache 2. So basically what we want to do here is we want to narrow this down until we just have our scored services running and anything that needs to be running in order to keep the system working. So if you're, say, you have a Linux system connected to a Windows domain, you might have some Samba stuff here that needs to be able to communicate with Windows in order for user accounts to work. You might have a web server that has a database on another system, and in that case you need to be able to, or some other web server might have a database on your system, in which case you need to allow traffic into that database still in order for those other systems to be able to make their web servers work. But basically what we want to do is we want to trim this down as much as possible. So we're going to look through this list and try to figure out what we need and what we don't. So here we have DH client is the first one. We don't need that because typically these are running static IP addressed things. In this case, on this specific system, I think I am running, this is getting its IP from DHCP, so I'm going to leave that on, even though it can't communicate, so it's not really a big deal. We'll also have RPC bind. Typically, almost every single time you can get rid of this. The only time you need this is if you're running an NFS share, a network file share, which you're typically not going to see. So we can kill that right now. So we're going to do a kill -9 448. Kill -9 says we're going to blow away this process. We don't care if it wants to stick around. It just can't. And then we can do the same for RPC stat D. You don't really need that unless you're doing some sort of statistic stuff related to DNS or something of that nature. You're doing some stats. So we're just going to get rid of that. I think that's what that's about. 457. So we're going to kill it by process ID again. Then we have SSH. We want to keep that running because that's a scored service. XM4 is a email system, so it'll accept email over SMTP. We don't need that, so we can get rid of that. 759. And then we have NC. So this is something sneaky I threw in there. This is a netcat listener that's listening on port 8080. So if we see something like this, we know that we've either been pre-compromised before the competition started by the organizers, or we've been compromised by another attacker. So if you see something like this, you want to track down where it came from. So we'll come back to that in a second. Then we have Apache 2, so we want to keep that. So we can run lsof npi again. Okay, so let me see this stuff. So you're going to want to kill all these netcat listeners as well, but before we do that, we might want to look into, see if we can find out where it came from. So if we do ps auxf, that gives us the trail of processes that spawned the netcat listener. So we'll do ps auxf, and we'll do a less, and we'll search for nc. So we see here, we have nc, we see it came from bash login, followed by bash, and then nc netcat listen on port 8080. So when you see something like this, so we say bin login bash, it means that this was created on login. So typically what that means is that you have a compromised Etsy profile or bash rc or something like that. So we can look in .bash rc, see if you can see anything in here. There's nothing in here. We can look in .profile in our home directory. Nothing in here. We can look in Etsy profile. Scroll around the bottom, and here it is. So we have this netcat listener. It's listening on port 8080, and whatever it gets, it pipes into bash. So if someone connected on this port, they could type a command, it would be run as root because we logged in as root. So I'll just delete this line and save and exit, and then I'll do lswf npi, and I'm going to kill all these netcat listeners. And 827, 859, 17, 185. We check back. And now we just have the stuff we want. So we have our DHCP client, we have SSH, we have Apache. Those are the three things we want to have running on the system. We don't really need DHCP, but I'll just leave it there. If you're running with a static IP address, you don't want to have DHCP running because it's pointless. And it just leaves you a little bit more vulnerable. So once you have this stripped down, next, this is the end of the critical security section. So once you're here, you basically just have your scored services to deal with. So what we do next is we're going to get into our application checklist and try to secure our services. So for SSH, we can go into the SSH config, SSH application checklist rather. And here it tells us to restrict authentication, so we can get into etc. Should probably use nano, SSH, SSHD config. And we'll scroll down. Most of this stuff is going to be default already. The most important things is permit root login is no. So we don't want to allow people to log in as root. We want them to only be able to log in as regular system users. We want to disable public key authentication. In a real world scenario, you really want to use public key authentication because it's super good and better than using regular passwords. But in competition environments, typically the organizers are not going to allow you to set up your user accounts to use public keys. So you have to use passwords. And so this just presents an opportunity for Red Team to be able to drop public keys onto your system in order to allow them to log in without having to use a password. So we want to avoid that if we can. Ignore our hosts is typically set to no already, and permitted empty passwords is usually set to no already as well. So most important things here: permit root login no, public key authentication no. So we're going to save this, and then we need to restart the service. So we're going to do systemctl restart sshd, or you can do service sshd restart. Either one of those should work. So now we can do, now we've got this done. You can also set up fail demand later on if you want to. It's not super important for security, but it can be nice if you want to automatically block IP addresses of your attackers if they try to log in and fail too many times. You can do that. I'm not going to get into that though. So next, let's look at the web checklist. So obviously, we want to change web app passwords, things like that. We're not going to get into this just yet. We'll get into that probably in a few weeks when we actually go over web things and databases. But the most important part for our web stuff is hardening php.ini. So if you're running a PHP service, you're not always going to be running a PHP service. You might be running something like Python or some cases Perl, but a lot of times you're running a PHP service. So we're going to go into, we're going to try to edit etc php. Let's see if we can get into etc php. Oh, this might actually not be installed yet. Let me install it quick. I have to update quick. That's strange. Oh, I know what's wrong. I'm not allowing anything outbound. Gotta fix my firewall quick. This is probably not a great idea to do during a competition to change your output. but it's pretty quick to change your outbound policy to accept for a second. Okay, let's try this again. Okay, so what we're going to do is we're going to edit. Typically it's going to be in Etsy, PHP 5, Apache 2, PHP.ini. In certain cases it could be in PHP FPM, PHP.ini, depending if you're running, say, Nginx or something like that. Or sometimes Etsy, Apache 2, PHP.ini. This is a good command you can use if you can't find the PHP.ini file, but we got it here. So in this file we have a bunch of settings for PHP. We want to change all of these settings, but the most important one is disable functions. So let's go to that first. Oh shoot, I hit Control W like a dummy. Okay, I've heard you can do Control Windows W. Yes, that works. So I'm going to search for disable_functions, and we have it right here. So they have a stuff in here already. We're just going to add to the end of this line. So we do shell exec pass through proc open popen system and PHP Info. So what these first, I believe, 6 commands do. So these are PHP functions that we don't want to allow the system to run. And what these do is they give PHP access to the shell. So with shell exec, you can write a PHP script which will run things as though you were on the Linux command line. So it'll run things in bash and give you some answer back. This can be a little bit useful in certain situations, but most of the time this is a very bad thing to have, because if an attacker can get on your system and write their own PHP script, they can execute arbitrary commands from the command line as the web application user. Usually that's www-data or Apache. So this is something we don't want them to be able to do, because if they can do this, they have access to the system as that user. Typically that user can just delete all of your web files. They can look into your configs for your web file and find your database password. They can do all sorts of crazy stuff that you don't want them to be able to do. So these 6 commands are commands that allow PHP people to get access to the shell or create new processes, and we don't want them to be able to do that. This last one here, PHP Info, gives information about the PHP system, the PHP, what modules are loaded, things like that. So you can say like, oh, I'm running this version of PHP, I'm running this version of this module. Usually that can give the attacker some information which they may be able to leverage into an exploit. So say you're running some old version of a PHP module, say an old version of PHP encrypt or PHP XML or something like that. If the attacker can find that information out, they might be able to find an exploit for that somewhere on the internet and use that to exploit your system. So that's just a little bit of obfuscation which can prevent them from getting in. I'm not going to run around and change all these other settings, but basically what these do is display errors off. Means that if the attacker is able to create some error to happen on the system, they won't get any information about how that error happened. Short open tag off. Basically it just makes it so you can't do really small PHP files. Max execution time of 3 means that a piece of PHP execution can only take up to 3 seconds to happen. So if an attacker is running some really crappy web shell and it just is running this in a loop, basically, it'll cut them off after 3 seconds and they won't be able to keep going. And there's a bunch of other things in here that'll get your security locked down a little bit. So after you've done this, we'll exit and save. Shouldn't have to restart Apache because this the PHP ini is loaded every time a PHP web page is loaded. So we're going to find the web user. So if we go to var www and HTML, so these are all of our web files. Typically they're going to be owned by www data. This whole directory is, especially depending on your system. And basically we want to ensure that the file permissions are restricted properly, so we find our user www data or something like that. We find the web directory and we want to chown, which is change ownership, recursively -R, the web user : the web user. So the user, we're going to restrict it to that user account and the group of that same user. And then the web directory. So that changes the ownership of all the files in there to that user. And then we want to change the permissions on all the files in that web directory so that it's only we want to remove write permissions for all user accounts that are not the web user. So what that basically does is that if permissions are too open, then other users can get in here. They can read configuration files. They can write to the web files, and we don't want them to be able to do that. So that's what all this stuff governs here. So running back here, we can do. This is a good time to do a remote backup. Basically, once you've gotten through step 9, you're basically secure. You're pretty much locked in. From here, we're just doing some safety stuff, so we can do a backup again. So you're going to back up all of your security changes that you just did. You're going to copy your backups to some remote server if you can, so that if your system gets nuked, you can recreate all of your systems and things on another system. You can reset up all your services and point things in the right direction and things like all over again. And then after that, we're going to do some just good security stuff. So we're going to check scheduled tasks. So in Linux, we have stuff called cron jobs. We talked about this in the Linux 101 a little bit. So if we see, we're going to create root/cron, and we're just going to move etc cron star. So all of the scheduled tasks, we're just going to throw in root/cron so that they're not run anymore. And we'll do the same to /var/spool/cron star. Once again, this is not something you want to do in the real world. In the real world, what you would want to do is actually look at these cron files, try to scan through them, see if there's anything malicious in there, make sure that there's nothing that's unnecessary or bad. Only stuff that you want to be in there is in there. But in the competition environment, that takes a long time, obviously, so we want to do it really fast, and typically stuff in cron is not actually pertinent to the competition. It's not really used very much. So another thing we're going to want to look at is we're going to look at etc/rc.local, like I talked about before. This is stuff that's run on boot. We looked at that a little bit earlier. So we can look in here to see if there's anything that looks malicious. We're not going to remove it though, because we want to keep it around for our Iptables restore. This next step is a little bit more tricky. I'm probably not going to go into it. But if you look in etc-init.d and etc-systemd, these are services that can be run at startup. So SSH and Apache will have their startup configs and things in there. This is a very sneaky way that attackers can add processes to your system. So that, like, every time you boot up, it'll start up this service and that'll get run. It'll start up a listener and things like that. It's very, very hard to actually scan through all of the stuff that's in these and find things. But a good thing you can try to do is do an ls-r of the directory, put it into a baseline file so that you can keep track of it for later. Then after that, you want to do install updates. Make sure that you modify your firewall rules so that you can allow outbound traffic. You can do your apt update, apt-get update, apt-get upgrade. That'll update and patch all of your stuff. And then very end, you can do some more interesting things like get rid of netcat, you can get rid of wget, get rid of curl, get rid of python. These are tools that you may or may not need on your system, but red team and attackers really like to have them because they're very simple tools they can use that are basically on every single system that they can use to get reverse shells, do persistence, things like that. At the very end, you can upgrade your kernel. It's not typically 100% necessary. Usually, we typically don't do this a ton because restarting the system, you're gonna have your services are gonna be taken offline for a while, and if things break when it turns back on, that is very, very bad. So this is something that's sort of optional. And then once you're down here, basically we get into monitoring. So you can just monitor your systems, keep an eye on things, keep watching LSOF NPI, keep an eye on this, run this every once in a while to see if any new processes pop up that are listening or calling out somewhere. You want to do PS FAUX or just a PS aux. So this is where our baseline configs come in. So you can do like a PS aux, put this into a file, PS. Now you can do a diff, so you can do diff PS and our ps.list that we created earlier. You can see what's different. So not a whole lot different here. You're still gonna have to scan through it and see if things look malicious or not. It's not a foolproof way to look at things, but I can give you a little bit of a better idea what things have changed on your system. You can look at top, see what processes are using up the most CPU. So if you have some crazy red team script on your system that's running in a loop for no reason, you might be able to catch it here. So yeah, PS aux with a diff. This is a really, really cool command that you can run. Basically what this command does is it looks for processes that are running on your system that are not part of a package. So if you install something on your system, if you install a service like SSH, it'll be associated with a package. And if, say, red team drops a script on your system that's running and is listening on some port, it will not be associated with the package, and so it'll get flagged in this command. So if we do this, we can do find at proc star exe exec read link plus xargs epackage rep no path. And we can see we don't have anything like that running, but if I do, say, like a netcat listener, I think it'll show up. No, it doesn't. So netcat doesn't show up because netcat is part of a package, but if, say, someone writes like a custom Python script or something like that, then that will definitely get flagged by this command. And then doing some more advanced things, you have like debsums -sa. You probably have to install it. Basically what debsums does is it tries to check to see if any of the binaries or any of the config files on your system have been modified since they were installed. It does this through hashes of the binaries. This can catch some things, not everything, but it's a good thing to look into. Auto desession logging is pretty advanced. We might get into that later in the semester, but I wouldn't worry about it too much right now. But there you have it. That is the Linux checklist. I think this took about an hour, but hopefully you find that useful. If you want to do well in these competitions like Cyber Conquest on the defensive side or the CCDC mocks that are going to be coming up, this is something you want to be very, very familiar with. People who have been on the competition teams, they can do this in their sleep. All of this stuff, very, very important, very, very good for securing your local system. So with that, good luck.